Hello guys. Am I audible? Let me know. Hi everyone. Let me know if I'm audible or not. Hello. Okay. So hi everyone. My name is Pradyumn and today we'll discuss the first four problems from today's CF round, which was CF Global Round 30. And so before we begin, I'll tell you about our courses at TLE Eliminators. So if you're someone who is stuck at just solving one or two problems per contest, then our self-paced courses are exactly what you need. We have structured this program into four levels so that you can start from wherever you are: beginner, pre intermediate, intermediate, or advanced. You'll learn the most relevant CP concepts through recorded video lectures by experienced educators, followed by carefully curated practice problems combined with guided hints and detailed video solutions that help you understand the why and not just the how. We believe in helping you build real problem solving intuition. If you need more help, you'll get instant doubt support from our high rated mentors, so you're never left stuck. And beyond learning, you can enjoy gamified progress tracking, leaderboards, internal contests, and PCDs like this one to keep you consistent. So pick the level that fits your goals and start learning today. And if you are not sure that which level you should choose, then you can watch this video to understand how to choose a level. And if you're still not sure, then you can watch the level specific video of any level. All right. So this video, which details the prerequisites, outcomes, difficulty, and topics discussed in that level. All right. So let's get started now. Um, so this was the contest. Yeah. So the problem A was called sequence game. Given an integer sequence of length n, denoted as a1, a2 up to an, and an integer x, you can perform the following operation. Select two adjacent numbers ai and ai plus 1 and replace them with an integer y, which satisfies the min of ai, comma ai plus 1 should be less than equal to y, should be less than equal to max of ai and ai plus 1. So y should be between ai and ai plus 1. After replacement, the original ai and ai plus 1 are removed from the sequence and the elements are renumbered from 1 to n minus 1. For example, if you have 1, 2, 4, 5, then you can select this 2 and 4 and insert 3. Then after you have 1, 3, 5, so you can, uh, but yeah, you cannot select like 1 and 2 and replace it with 3 because 3 is not between 1 and 2. Alright. After performing an MNS operations, only one number will remain. The question is that whether final number can exactly equal to x. Okay. So what they have asked is that we have been given an array, right? A1, A2, up to AN. And what we can do is in one operation we can select any two adjacent numbers, that is some AI and some AI plus 1, right? And we can insert a number, like we can erase those from the array and insert a number y such that y is between AI and AI plus 1, right? So we'll do this operation like, okay, this length changes to n minus 1. Initially it was n, now it changes to n minus 1, obviously, because we removed two numbers and inserted one number. So when we keep doing this, after we do this n minus 1 times, finally one number will remain in the array, right? So can that final number be equal to the given number x? Like x is given in the input. So can that final number be equal to x, right? Okay. So first of all, let's look at some samples. Okay. So let's say we have this 1 minus 1 minus 4. 5 1 minus 4, and we have x equals to minus 2, that is we want to make minus 2. So what I can do is, um, I'll just show you how to make minus 2. It is possible. Okay, so let's say we take this 1 and minus 1 and replace it with, let's say, 0. Okay. Then we take this 0 and minus 4, we replace with minus 3. Then we can replace this 1 and minus 4 with something, let's say 3, or not 3, we cannot replace it with 3. We can replace it with 0. Okay. So 1 and minus 4 to 0. And this 5 and 0 to anything like, let's say 3. And minus 3 and 3, we can replace it with minus 2. So we get minus 2 at the end. So since I performed the operation and make minus 2, like I made minus 2, that's why the answer is yes. Like I am able to make minus 2, so the answer is yes. But so what is the condition that when will you be able to make minus 2 or not? Or any x? When will you be able to make some x? So first of all, it is very obvious that any number that you insert will be between those two numbers that you remove from the array, right? Like any number that is there in the array will definitely be between those two numbers that you remove. So like you cannot really insert any number which is less than the minimum or more than the maximum, right? Like if you see here, the array was this 1 minus 1 minus 4, 5, 1 minus 4. So the minimum is minus 4 and the maximum is 5. So obviously you cannot insert 6. Like there is no way that you could ever have 6 at the end. Like the array can never have 6 inside of it. Because any new number that you insert, it will definitely be in between some two numbers. So we can definitely say that they will be between minus 4 and 5 also. Like it cannot be, like we cannot insert minus 5 because that is less than the minimum value. Okay. Right. So definitely, if x is greater than max, or this is or x is less than min, then the answer is no. Okay, you cannot make x because that number can never occur in the array. And if not, like basically, if x is between max and min, like if the minimum number is smaller than equal to x and is smaller than equal to max, then we can actually always make x. Okay, we can always make x. All right. And why is that so? Basically, I can just give you an algorithm to make x. Okay. So like, see, here, this is the minimum element. Okay, I'll just show it here and then I'll show it in generalized. So, okay, here's the minimum element. Here's the maximum element. Or let's change the array a little. Let's say here was 1 and here was 5. So here's the maximum element. And you want to make minus 2. So minus 2 is possible, okay, because it is between minus 4 and 5. But how do we make it? What we can do is just take this minimum value and eat all of the elements beside of it. Like basically just take this minus 1 and minus 4 and replace it with minus 4. Like delete these two elements and insert minus 4. So essentially this minus 1 is being, this minus 1 has been eaten by this minus 4, right? Then take this 1 and minus 4 and replace with minus 4. So this 1 has been eaten by the minus 4. And similarly, eat this 1 also, right? And now you can eat this minus 4 with this 5. Like just take this 5 and minus 4 and replace it with 5. Okay, just replace this with 5. So this minus 4 gets eaten. So in the end, you are left with the minimum and the maximum. And so you can just replace them with whatever x is. Because x is in the range of that, right? So that is the algorithm. Like I'll repeat. Let's say you have this array. Let's say you have minimum here and maximum here. Then you can simply like you can let's say this is minimum. Okay. Then you can choose these two numbers and replace it with the minimum, right? Like you can always take x and y and replace it with x, right? Because it will also satisfy that condition. Like you can take any two numbers. I mean, this y can definitely be ai or ai plus 1, no matter what, right? Like if you have on a number line, this is ai, and let's say this is ai plus 1, then you can definitely take AI, right? Because it is in between AI and AI plus 1. And same goes for AI plus 1. So you have minimum here, and you can just eat the neighboring elements and replace it with minimum. Replace those two elements with the minimum. So you can just delete all of these elements essentially. And this is maximum. So you can eat this element using the maximum, right? So you can just eat all of these elements, and so finally the minimum and maximum will remain, and then you can just replace this minimum maximum with your x, because this x lies between those two values. Okay, so the final condition is that if the x lies between the minimum and maximum, then the answer is yes, otherwise the answer is no. Okay. Okay, so I think it should be clear to everyone. If there's any doubt, then you can ask me. I'll show the code meanwhile. So we have n and x, c in n. Take the input of the array and take the input of x. Like, I don't know why they have given the input like this. Normally it should be n and x and then the array. But okay. Then I find out the minimum element and the maximum element. So if x is less than or equal to maximum and x is greater than or equal to minimum, then the answer is yes. Otherwise the answer is no. Okay. So let's go to problem number B. Even modulo pair. You are given a strictly increasing sequence of positive integers, a1 less than a2 less than up to an. Find two distinct elements x and y from the sequence such that x is less than y and y mod x is even. Or deduce that there is no such pair. Okay, so this problem is very nice actually. Like, many facts have been used. Like, the statement is very short, but in the solution, many tricks have been applied to solve this. Okay, so let's understand what is happening here. Like, what is the problem is that you are given an array a1, a2, a3 up to an, right? And it is increasing array. So a1 less than a2 less than a3 up to less than an. And you have to choose any two numbers from the array, let's say x and y, where x is less than y, such that y modulo x should be equal to an even number. Okay, so y mod x should be even. So you have to find out any such pair, or say that it doesn't exist. Okay. So of course, O of n square solutions is very obvious. You can just iterate over all pairs, but you cannot do it in O of n square because the constraint don't allow you to do it in O of n square. So you have to do it in O of n or n log n, right? But what do we actually do in this? So one thing to observe. Okay, so we want y mod x to be equal to an even number. Okay. So if y and x, if they are both even, so even mod even, that is definitely even. Okay, that is for sure, right? I think this is clear. Like, even mod even is always even, right? Because let's say if you are doing a mod b or y mod x, that means you are writing y as some quotient times x plus some remainder. And if x and y are both multiple of 2, then for this equality to hold, r also has to be multiple of 2, right? So y mod x would be even if x and y are both even, right? So if we have two even numbers in our array, then our job is done. If we have two even numbers, then it is done, right? Okay. But what if in our array we don't have two even numbers? That is, we have only a zero. Like either we have no even numbers or we have only one even number, right? That is the case that is left. So if we have two even numbers in our array, then our job is done, and it is pretty easy to detect that whether or not we have two even numbers in our array. Now, for the second case where we don't have two even numbers, okay. So let's consider other cases, like what is odd modulo even. So odd modulo even is always odd. Okay. So definitely you won't report this answer. But what about odd modulo odd? This you can't say. Okay. Like for example, 5 mod 3 is 2, which is even. But 7 mod 3 is 1, which is odd. And what about even modulo odd? Even modulo odd, this also you cannot say because 8 mod 3 is 2 and 10 mod 3 is 1. So this is even, this is odd. So you cannot really say anything about them, right? Because the problem is basically these two numbers go different number of times in 5. Like uh, 3 goes once in 5. Like 5 by 3 GIF is 1. Whereas 7 goes twice. I mean 3 goes twice in 7. That is 7 by 3 ka GIF is 2. So since this difference is there, like in the quotient, that's why the remainder has changed. Like ideally, if I have 5 mod 3 it is 2, then 7 mod 3 should be 4, right? So it should be even. But since 4 is greater than 3, that is we can accommodate one more 3 in this 7. Therefore, it has become odd, right? Okay. But the thing is that for odd modulo odd, like my point is that odd modulo odd, it may be odd or even, right? Even or odd. Okay. But the thing is that for it to be odd, like for this odd modulo odd to be odd, um, it has to be the case that, like, okay, let's say we have my mod x, y mod x, and it is odd, where y is also odd and x is also odd, right? Then for this to be like for this to happen, y has to be greater than 2x. Like what I am saying is, let's just take examples. Okay, like we have 5. Let's say x is equal to 5, and y. Let's say we change y. Let's say if y is 5, or yeah, let's say y is 5. Then what is the remainder? Like 5 modulo 5 is 0. Then let's say y is 7. Okay, y is 7. So 7 modulo 5, what is it? First of all, 7 modulo 5 is just 7 minus 5, right? Because 5 goes only once in 7. So 7 minus 5 is 2. Then if we keep y equals to 9, then 9 modulo 5 is 4, right? So as you can see that this odd modulo odd is coming out to be even. And why is that? Like basically my point is that when you do y modulo x, and this x goes only once in y, like if this ratio of y by x, if it is less than 2, that is if this GIF of y by x is equal to 1, then our y modulo x is just y minus x. This is the entire observation. That if we want odd modulo odd to be equal to an odd number, then y has to be large. Like, okay, I'll show you more examples. Let's say we have 15. X is equal to 15. That is, we are taking mod with 15. So if you take 17 mod 15, then you will get 2. If you take 19 mod 15, you will get 4. So and so on. Like if you take any y mod 15, it will be y minus 15 only, as long as this y is up to 29, right? So as soon as you power 30, like let's say you use 31, so at this point 15 goes twice in 31. So in that case it again comes down to 1. But until a certain point, like until 2x, you can say that this y mod x will be y minus x. Like what I'm saying is, if y is less than 2x, then y modulo x would definitely be y minus x, right? And if they are both odd, if they are both odd, then this value is definitely even, right? It is definitely even. Okay. So if the checker, like if the problem wants to give us an input, like let's say it gave an input a1 less than a2 less than a3, let's say five numbers are there, less than a4 and less than a5, and let's say they are all odd numbers, they are all odd numbers. Okay, so okay, now let's say a1 is this, a1 is let's say 5. Okay, so to ensure that this a2 mod a1, like basically we are trying to make an input, we are trying to make an input for which the answer is minus 1. Like um, there are no pairs such that y mod x is even. Okay, so let's try to do that. Like let's say a1 is 5. Then if I want that a2, like a2 mod a1, a2 mod a1 should not be equal, should not be an even number, and I want this to be odd, then of course I have to at least double it. Like I cannot keep it 7 or 9, because if I keep it 7 or 9, then the modulo will be 7 minus 5 or 9 minus 5, which is even, right? So I have to at least double it. So let's say 11. So now 11 modulo 5 is odd. Okay. Now let's say I want to insert one more odd number, a3. So again I have to at least double it, right? Because if I keep 13 or 15 or 17 or 19, then their modulo would just be 13 minus 11, which is 2, which is even, or 15 minus 11, which is 4, which is also even. So I have to at least keep it 21, right? So as you can see that at every point, the numbers have to at least double in order to ensure that the adjacent ones are not even modulus, or not 21, I mean 23. So my point is that if we have all odd numbers in our array, then they have to at least become double of the previous one if they want to ensure that minus 1 occurs. Like if they want to ensure that these adjacent elements are not satisfying the condition, then they have to at least double. Okay, if they are odd. That's the entire observation here. Like I'll just write it. The first observation is that if y is less than 2x and x and y are both odd, right? Then y modulo x is just equal to y minus x, right? And which is an even number. So if you can find out a pair such that y and x are both odd and y is less than 2x and of course greater than x, then you can just print that, right? So that means that basically if all numbers are odd, if all the numbers are odd, then at each step it should double. It has to double, at least double, right? That is, if I have 11 here, then the next number cannot be 13 or 15 or 17. because their mod would be just 70 minus 11, 50 minus 11, 30 minus 11, and that would be even, right? But actually, this is not possible, right? Because the constraints on AI, the constraints on AI are just 10 to the power 9. And like if you double 30 times, like let's say you start with 5, and then you have to put 11, right? Then you have to put 23 to ensure that it is not by the previous one. Then you have to put at least 47. So, like when you keep doubling, so if you let's say double 30 times, okay, then your final number would like the current number would just be at least 2 to the power 30, right? And this 2 to the power 30 is already greater than 10 to the power 9, right? So therefore, if n is large enough, if n is large enough, like if let's say n is larger than 30, then definitely you will get some index. You will get some index where the value is not doubled, right? You can find some index where the value is not doubled, like it is less than doubled. Like if here is x and here is y, then y is less than 2 into x, right? Because if at each step it was doubled, then the last value would go out of range, right? So if n is at least 30, then you can definitely find a pair such that y is less than 2 into x, and also x and y are odd. Like we know that all the numbers are odd, right? Or okay, let's say one is even. Still, if only one is even, then also you will find some pair such that y is less than 2x, right? And then you can just print that pair. So basically, just check all of the adjacent pairs. First of all, just check for this condition that if there are multiple even numbers, like if there are more than two even numbers, two or more than two, then you can just print those two even numbers, right? Then if n is at least 30 or let's say 35, just to be safe, then you can actually just check adjacent places, because you will definitely find some index where the value is not doubled, it is less than doubled, and both are odd. See, both are odd, you will find, because there's only at most one even number in this entire array, right? So you will find a certain index where both are odd and the value is less than doubled, right? So you will just check all of the adjacent elements, and if any one of them, like you will definitely find some element where y mod x is even. Okay, you will definitely find some index. And if n is less than 30, then you can just brute force. Like if n is less than 30, or let's say 35, then you can just do O of n square. And if you don't get any pair, then just print minus 1. I think, okay. Yeah, like this was pretty tough to think of. Like I felt that this B was tougher than C and D. But okay. Like this was a pretty tough problem. I don't know why they gave us B, but okay. Um, Initially I forgot a new line in this submission, like print NL. I forgot that, so I wasted 17 minutes and one wrong submission. And those 17 minutes affected the other two problems as well. Like C and D, they were late by 17 minutes. So, anyways, your idea won't work for last shown test case. No, see, what the thing is that okay, you did not understand what I was saying. I was saying that um, let's say if all are odd, all numbers are odd. Okay, my idea is My idea is check all adjacent elements. Check all adjacent elements. Right. So how, like, when will this idea fail? Let's see. So first of all, like, let's try to create an array where my idea fails. Okay. So let's say A1 is something 5. Okay. Then the next number. Okay. First of all are odd, right? All of them are odd. So what the next number can be? Can it be 7? No, it can't be because the mod is 2. 7 modulo 5 is 2. It cannot be 9 also because it is 4. So it has to be at least 11, right? So let's say 11. Then what's the next number? Let's say it is 23. Like, it cannot be 13 because 13 modulo 11 is 2. It cannot be 15 because 15 minus 11 is 4, or 15 modulo 11 is also 4. So, like, as long as I am less than 22, like up to 20, up to 19, or even 21, up till 21, the modulo of this with this would just be their difference, right? Like for 13, 15, 17, 19, and 21, the modulus would just be the difference. Like 13 modulo 11 is 2, 15 modulo 11 is 4, 17 modulo 11 is 6, and so on. So you have to go at least till 22. Like you have to go above 22 in order to make the modulo odd. Okay. Because otherwise it is just the difference, and odd minus odd would be even. So you will get even, right? So in order to refute my idea, you would have to put 23 here, right? 23. So you have to at least double it. Okay. At least double it. Then you have to put 47. Like if you put anything less than 45, even 45 also, then also the modulus will be 22, like the difference. So you have to double it. Like you have to at least double it at every step. But the thing is that you cannot really double it many times. Like if you keep doubling this, then eventually you will reach 10 to the power 9. Like this element limit is 10 to the power 9, right? So you can only double it around 30 times. If your array size is more than that, like if your array size n is greater than equal to, let's say, 30, then it is not possible to refute my idea using only odd numbers. Like if n is at least 30, if n is at least 30, then definitely there will be some index where the element is not doubled. Like the element is not doubled, there must be some index. Because at every step, if it doubles, then the last element will blow up, right? So my entire point is that you can always find some index if n is sufficiently large, such that that index, like at that index, it is not doubled, right? And you can just print those indices. And like the third test case is not, like, my idea doesn't go for third test case because here also they have doubled, right? This 117 is more than double of 17, and this 1117 is more than double of 117. So they can do this because the n is small, right? N is less than 30. But if n is greater than 30, then it is not possible to do it. So you can, if n is less than 30, you can just brute force, like just apply O of n square. Just check all of those pairs and print -1 if you don't find anything. And if n is greater than 30, then you will definitely find something. Okay, assuming that they're all odd. Like if there are at least two events, then you can simply print them. So first of all, just check for events. Like this is the code. Just check for two even numbers. Okay, just check for two even numbers. Or look, okay, I'll just, what I did was if n is less than 1000, then just I did n square because n square will work in that case. So if n is less than 1000, just do n square. Otherwise, just check if there are at least two even numbers. So if even numbers dot size is greater than 2, then just print any two even numbers. And otherwise, just check all of the adjacent numbers. And it works. Okay, this was your doubt. Ashish, I'm not saying that. Wait, what is your question? Like, I don't understand. Normal brute force is working for n square. Like, what do you mean normal brute force? Like, many people got TLE, right? On B, got it TLE. Let's say C++ level. So there are TLEs, right? This is n square. Or okay, I don't know what this is. What are they doing? But I don't think n square would work. Like, what do you mean by brute force? Are you checking for this condition first? Like, are you checking for this even number condition? Something like this, like, uh, do you mean this? I'll try to submit this. Let's see if it passes or not. I mean, maybe it would pass. Not sure. Actually, the reason it passes is because it is very tough to generate such test case. Okay, it is passing. Actually, it is. Yeah, doubling logic is the proof. I mean, not really. Um, okay, yeah, yeah, true, true. Like, see, if you are checking like this, like let's say you are doing this. Let's say this is your array, and this or array of length n, right? And all are odd. Okay. So first you check these two pairs, then these two pairs, then these two. So my point is that um, since I said that 2 to the power 30 is greater than 10 to the power 9, right? So in the worst case, like in the first 31 numbers, there must be some pair. Okay. There must be some pair which is not double. Like y is less than 2x. There must be some pair in the first 31 numbers, right? So what you guys are doing, like let's say this is 31 numbers, assume that this is 31 numbers, and the rest of the numbers are somewhere here. So what you guys are doing, you are checking this and this, then these two, then these two, then these two, then these two. So let's say it doesn't find anything until n. So it will take n steps to do this. Then it will check these two, then these two, then these two, then these two, and again, let's say n minus 1 steps more, right? But it will have to do this at most 30 times only. Like when it reaches here, like if it did not find out any pair from out of these, then that means all of them are doubled, right? So definitely this pair will not be doubled. So you will find out the pair in 30 into n iterations. Like there is definitely a pair which exists in the first 30 numbers. So you will find it in 30 iterations if you do the loop like this. Got it, Avi? Yeah, it is kind of beautiful. Okay. So let's move on to the next one, I guess. Dungeon. You are now in a dungeon N swords facing M monsters. The damage of the ith sword is AI, and the life value of the ith monster is BI. A sword with damage X can kill a monster with life value Y if and only if X is greater than or equal to Y. That is, if the strength of the sword is greater than the strength of the monster, then it can kill it. After killing the ith monster with a sword of damage X, this sword disappears. Then, if CI is greater than 0, you will obtain a new sword with damage max of X, CI. Otherwise, you will get nothing. Now you want to know the maximum number of monsters that you can kill. Note that you can kill each monster at most once. Okay. So the problem is that you have like n swords, right? So let's say, how do I draw a sword? Let's say this is a sword, or leave it. These are swords. Okay? You have n swords and m monsters. Okay. Let's say these are the monsters. Circles are monsters and the lines are sword. So you have m monsters and you have n swords. And what is there? So every monster has a sword itself. Like, see, for each monster we know two values, BI and CI. Okay. So BI is its health or its strength. Okay. So we can take a sword of strength X and we can kill monster M with that if X is greater than or equal to BI. Right. So the sword strength has to be greater than or equal to the monster strength if we want to kill it. Right. And then what will happen is we will get a new sword. Like if CI, if this CI is greater than 0, then we'll get a new sword with strength of max X, CI. Right. Otherwise, we will not get anything, and this sword also will be destroyed. So basically, we'll be left with one less sword, right? So finally, we have to optimally play such that we kill the maximum number of monsters, right? So let us see how do we do this. Now, actually, to visualize, like this problem is pretty easy to visualize. Like what you can think of it like, you can think of it as if there are many monsters, right? There are many monsters, and sorry, yeah, there are many monsters, and each of them has squad. Like for all of them which have CI greater than 0, they have a sword, right? Which have a strength of CI. Okay. So let's say you kill this monster using your X sword, right? So either you can keep using your sword X, or you can pick this sword up. of this monster, right? Like basically, let's say your value of X was 4, and this monster's health was 3, and it had a sword of 6. Like basically, BI is 3 for this monster, and CI is equal to 6. Then you can kill him, right? And this monster drops a sword of strength 6. So either you can choose this one or you can choose the 6 one. So of course you will choose the 6 one, right? But if the monster doesn't have a sword, that is, if CI is equal to 0, and let's say this BI is 2, then if you kill this monster, then there is no extra sword, and also your sword is also gone. So this is the little caveat that you are punished for attacking this helpless monster. Like, okay, because it had no defense and still you attacked it, so now your sword is gone. So you can think of it like that, and doing that really helps because um, basically you can see that killing a monster with CI not equal to 0. Like let's say there are some monsters with CI equal to 0. Let's say for this CI equal to 0, for this equal to 0, for this it is not equal to 0, and for this also is not equal to 0, and for this also is not equal to 0. So there are some monsters with CI equal to 0 and some with CI not equal to 0, right? So the thing is that whenever you kill a monster with a sword, 2, 3, 4, 5, let's say, you have these 4 swords with values 2, 3, 4, and 5. So whenever you try to kill a monster with your sword and the CI value is not equal to 0, then you face no loss. Like what I mean to say is, the sword that you initially have, 2, 3, 4, and 5, you will end up with at least that. Like when you attack it, like whatever the value of CI is, let's say if CI is 1 and you attack this with 4 value, then it will still remain 4, right? But let's say if CI was 7 and you attack it with 4 sword, then it will become 7, right? So, like when you attack any monster with CI not equal to 0, it will always improve your position. Okay. So, what I'm doing is attacking, like what I'm saying is attacking a monster with CI greater than 0 always improves our swords. Like always, like never, basically, never decreases our sword. Okay. That's the thing, that attacking a monster with CI greater than 0 never decreases strength of our sword, right? Like whatever our set of swords is, it is not decreased. Okay, so we can attack it. But the thing is that attacking these zero number monsters, that will destroy our sword. Okay, that will definitely destroy our swords, right? So what do we do? Like, what's the optimal way to proceed? So of course, if attacking any of these monsters which have non-zero CI, if it doesn't harm us, then of course we will attack them before. Like first we will attack these ones, the non-zero ones, right? And then whatever we can attack in the zero ones, we will attack them, right? So first we will attack the non-zero ones, and then we'll attack the zero ones, because attacking the non-zero ones will never harm us, right? So what we can do is first attack the non-zero ones, and then the zero ones, right? Because attacking the zero ones harms our case. Like whatever we attack them with, that's what will be gone, right? And attacking the non-zero ones improves our case, or it doesn't harm our case. So we can always attack the non-zero ones. right? But the thing is that how do we attack the non-zero ones? Like maybe the way that we attack the non-zero ones will affect the number of monsters that we are able to kill in the zero ones. Like I'll take an example. I hope there's an example somewhere. Like see, if we have 1535 as our sword, we have four swords, 1535, and the monsters that we have. So we have 7040. So they are the health. Like to kill them, we need to win at least seven, win at least four, right? Uh, 6 1 and 5 6. So actually, in this case, it is not a good sample. Okay. So what I'll do is I'll make a better one. So let's say we have this sword. Uh, Only one and five we have. Okay. And this is, let's say this is seven. Or wait, how do I do this? Let me just think about it, guys. 1 minute. Let's say we have two and three. Let's say I have one and seven, two and seven, and then let's say I have six and zero, six and zero. Right. So just take this test case, guys. Like here I have the swords two and three initially, and there are two monsters with CI equal to seven and seven, like both seven, and there are two monsters with CI equal to zero. So in this case, what is the answer? First of all, just tell me the answer. Like in this case, what is the correct answer? Four. Yeah. Why? Because you can kill, let's say, this monster with this sword, so it becomes seven, right? It becomes seven, and then you can kill uh, this monster with this sword, so it becomes seven, right? And then you can kill both of these with these two swords. But if you mistake, like if you did a mistake, and like you killed um, this one, let's say, using this three, so it became seven, right? And then with this one only you kill this one, this monster, so it will remain seven. But now when you kill this monster, this sword will get destroyed, and you cannot kill this monster using this sword, right? So you need to be careful in what way you are destroying the monsters, the non-zero monsters, right? So you want to maximize your sword collection. Like you want to kill the monsters in such a way so as to maximize your sword collection. Okay, but how will you do that? Like what will you do now? So let me ask you a question. Okay, let's take a test case. Um, the test cases are pretty bad. So let me just draw myself. Let's say we have two, three, and four are swords. Then let's say we have three, five as a one monster. Um, three zero as one monster. Four zero as one monster, and five zero. Or let's say not four. Let's just take 5 0. Um, and let's say 4-0 as well. Okay, this is nice. Yeah, so you have three swords, 2, 3, and 4. You have one monster which is having health value as 3 and reward as 5, and two monsters are there have health value 5 and 4 but reward as 0. Right? So you will definitely attack this monster first. Like you will definitely attack the non-zero monster first. But which sword will you use to attack it? Which sword will you use? So you have this 2, 3, and 4 as your swords, and you have 3, 5 right here. That is a monster with health 3 and reward 5, and there are two other monsters. So first you will kill this, of course. First you will kill this, but which sword will you use to kill it? 2. You cannot kill it with 2 because its health is 3. Like killing by 2 is not possible because the health is 3, right? So Chandan says 3, right? So that is correct. So we will kill it using the sword number 3. I mean the sword with strength 3, and that will make this strength as 5, right? And then we can just kill this 4 with this 4 and this 5 with this 5. So you have killed all the three monsters. So by this example, actually we had two options, right? We had two options. Either we could kill with 4 or we could kill with 3, right? So let's say if we had killed with 4, then we would have gotten 2, 3, and 5. Like after killing this monster, we would have gotten 2, 3, and 5 in our armory, right? And but if we kill using this 3, then we get 2, 5, and 4, right? So here this 2 and 5 is common. 2 and 5 are same, but this 3 and 4 are different. So of course this 2, 5, 4 is better, right? So always you will kill using the lower one. Like always you will kill the monster using the lowest strength sword that you can get, so that the remaining ones are higher, right? Like what for example if I give you 2, 3, 4, 5, and there's a monster with 3 and 6. So you have three options, either to kill with 3 or to kill with 4 or to kill with 5. So if you kill using 3, then it will be 2, 6, 4, 5. If you kill using 4, then it would be 2, 3, 6, 5. And if you kill using 5, it would be 2, 3, 4, 6. Right? So here you can see that 2 is common in all of them and 6 is common in all of them. Right? So in one place you have 4, 5, in one you have 3, 5, and one you have 3, 4. So of course this 4, 5 is the best because 4, 5 is better than 3, 5, and 3, 5 is better than 3, 4. So yeah, this 4, 5 is the best. So basically you have to remove the minimum one. So if you want to kill a monster, the observation is that if you want to kill if you want to kill a non-zero monster, then use the weakest possible sword. Use the weakest possible sword. Okay, right? This is the observation number one. But now the question is that what if there are multiple non-zero monsters? Which one should we kill first? Like what if there are multiple monsters which are having non-zero reward? Then which one should we kill first? So do you guys know that? Can you guys think about that? Which have more recovery power? No. See, I will give you a counter test case for that. Let's say you have a 2 and 7 and a 5 and 6 or 5 and 8, and you have a sword of strength 3 and 4. Okay. So if you kill the monster first, which have more recovery power, like let's say basically you sort the monsters in the reverse order of recovery power. Then what you will do is you will sort this like this, that you will first put 5 and 8, then you will put 2 and 7, right? So then you will try that, can you kill this 5 comma 8? You can't kill 5 comma 8, right? Because in your swords all of them are less than 5, so you can't kill it. Then you will go here and you will kill this using the sword number 3, and it will become 7. You will do this, right? But actually the correct thing to do is you can first kill this 2 comma 7, right? So using the sword number 3, using sword 3 you can kill 2 comma 7, so it will become 7 comma 4. And then using the sword 7 you can kill 5 comma 8 also, so it will become 8 comma 4, right? So that's why higher sword value, higher recovery power doesn't work, right? Saksham, I explained why it gets accepted, so you can check that out. Like you can rewind the video, right? Solution to CP, Siddharth. Did you guys get it? Like why does it work? Like it might happen that you get some reward after that, and then you are able to kill it. Yeah. So like the main problem here is, um, it might happen that you skip a monster for now, but then you get a lower monster, like a lower health point monster. You kill that, and then you realize that you are able to kill this previous one after killing this one. So that shouldn't happen, right? That is not what we want. So instead, what we can do is we can kill them. We can kill in increasing order, increasing order of health. Okay. So why do we do that? So actually, the thing is that it ensures that let's say we have this test case only. So okay, let's say we have some monsters. Let's say one monster, second monster, third monster, fourth monster. So okay, first of all, if we are able to kill this monster right now, like first of all, this is arranged in increasing order. So it is arranged in increasing order according to this. Like what I'm saying is that these four monsters are arranged in increasing order according to their health points. Okay. So what I'm saying is, if right now, like with whatever swords you have in your armory, if you are able to kill this one as of now, then of course you'll be able to kill this one and this one also, because they have lower health, right? And if you first kill this one and this one, then you will have a better armory. Like you will definitely have a better or the same armory. So you definitely at that point also you will be able to kill this one. So there is no loss in killing these two first. Like if you kill these two first, and then also you will be able to kill this one. Like if you are able to kill this one now, then definitely you will be able to kill this one after you have killed these two. So you will start with the lowest health point first. Okay, you will start with the lowest health point and keep killing. And let's say you cannot kill this one. Okay, like let's say this is too much health point. You cannot kill this one right now. then definitely you are sure that you can never kill this, because the ahead ones are even more in strength. Like the next ones are even more in strength, right? So you cannot kill them also. So definitely all you can kill is these three ones. So that's why that's why you have to kill the non-zero monsters in increasing order of their health. Okay. Yes, yes, non-zero CI numbers. Like we are first killing the non-zero ones, and then we are killing the zero ones. Higher value of BI minus CI. I mean, BI minus CI doesn't matter. Like I proved why killing with BI is correct. Like I just showed you why killing in increasing order of BI works. In order of increasing health, and then selecting one with higher sword value. Um, like I don't understand what you did. Anyways, I'll take it later. So what I was saying is, what you will do is you will first kill the non-zero monsters. You will kill the non-zero monsters in increasing order of their health, right? And you will use the weakest sword. If you want to kill a non-zero monster, you will use the weakest sword possible, right? So if you apply these two greedy algorithms, you will get the best possible armory when you reach the zero swords. Like, when you reach the zero monsters, you will get the best possible armory, right? And then what you can just do is kill them, like one by one. Just go through the monsters. Like in the zero monster also, the third step is kill the zero monsters, kill the zero ones, and they also in increasing order of health, right? Like just kill the weaker ones first. Okay, and like use while using the weakest sword possible, while using the weakest sword, right? That's the algorithm. Yes, lower bound of BI, lower bound of BI, right? So yeah, that is the solution. Does anyone not understand what I said? Any doubts, anyone? You can use a set, a multi set of swords. Okay, like in C++, you have multi set, right? It keeps the elements sorted, and you can erase, and you can insert, and you can use lower bound. Yes, like in set it is supported, right? In set and multi set, you can do lower bound and upper bound, and it takes login time to do that. Any tips for the fourth problem? Um, like it just depends on how the fourth problem is. Like if it is some, if it is based on some theory, then of course you need that theory in mind. But mostly in CF, like okay, I'd say 50-50. Like half the times it is not a theory, and half the times you will need some basic theory to solve it. Anyways, let's move on to the fourth. Or okay, let's see the code now. Okay, so I have NM, CNM, and a multi-set of swords, right? So I fill the multi-set, and then I have a pair of monsters. So the first in element stores the BI and second stores CI, right? So then I just sort it. I sort the monsters according to the BI value. Okay. Then I have to print the number of monsters that I kill, right? So I just count that. So I have this ans variable, and I'll increment it whenever I kill a monster. So I'll iterate from one to like over all the monsters, and if it is zero, like I'll first only do the non-zero ones. So if it is zero, then it is continue. Then like then what I'll do is I'll find the lower bound in my multi-set of the BI value of this monster. If it is dot end, that means it could not find any sword. Then that means we cannot kill any more monsters, right? Because we are doing it in increasing order. So after this point, there will be even more health. So we cannot kill them. So we'll just break. And otherwise, we will remove that sword, right? And we will insert max of x comma ai dot second, right? That is what happens when we kill a monster, and ans plus plus because we killed a monster. So in this loop, we are killing the non-zero ones. Then in this loop, we will kill the zero ones. So if ai dot second is dot zero, then continue. Then we'll kill the non-zero ones with lower bound again. And if it is equal to end, then break, of course. Otherwise, just erase that sword because when we kill the zero one, we lose that sword. So we erase it from our multi-set and ans plus plus and see out ans. Okay. All right. So let's move on to D. Copy string. Given two strings s and t of length n, you aim to transform s into t through a series of the following operations. Construct a new string s dash of length n, where the first element is same, and for each n, like for each I from 2 to n, si dash s dash of I can be either si or s of I minus 1, and then replace s with s dash. Your task is to achieve this transformation using the minimum number of operations. You also need to output the solution by printing the constructed s dash after the operation. If the transformation cannot be achieved in less than or equal to k max operations, then output minus 1. Okay. So what they are saying is that we have a string, right? Let's say we have A, B, C, D, E. Okay. And we want to convert it into some other string. Okay. Let's say we want to convert this into A, B, C, C. Okay. And we can do some operations. Like we can do some operations to convert this into this. Right. And what is the operation? The operation is that we can create a new string of the same length where the element one would be same. The first element would be same, which is A. Then this element can this element can either be B or it can be A. This element can either be C or it can be B. This element can either be D or it can be C. And this last element can either be E or it can be D. Right. So let's say we want to make this tree which is A B C C. Okay. So what can we do is we can put A right here, right? Then we can put B here. We can put C here, and let's say we just put D here or something. Okay. Then one more operation we can do. Like again, we can do same operation. Now what we can do is, of course, here it will be A only. Then here, let's say here, of course, we have only one option A. Then here it is B only. Then I mean either we can choose this B or this A, but let's say we choose B, right? And then we have C here. Like either we can choose B or C, but we can choose like we will choose C. And here we can choose either D or C, so we will choose C, right? So as you can see, our final string has become our target, right? So we want to just print these intermediate strings, okay? And we have to do it in the least number of operations possible, okay? So how do you actually solve this? So like this operation thing, right? It is pretty confusing to understand that actually what is happening. Okay. So to add an intuition, you can think of it like these letters. These letters are moving forward. Like these letters, they are moving forwards. This B is moving forward, A is moving forward, right? So as you can see that this B came here, like from the index number 2, it came to index 3, and this A also it came to index 2. I mean it is there at index 1 also, but you can simply think of them like they are moving rightwards, right? So let's say if you have a string which is, let's say, A B C D E, and if you want to convert this into A B C E D, okay, or let's say E E, okay, then it is not possible. It is not possible. Why? Because how can E come here? How can E come here? It cannot come here, right? Because the elements are moving from left to right. Like we can move this A from left to right, B from left to right, C from left to right, but there is no E to its left. There is no E to its left, so you cannot really get an E right here. Okay, that's why the answer to this one would be no. All right. So yeah, the first thing is like the first thing to observe is that the letters are moving rightwards, right? And one more thing to observe is that the relative order is preserved. The relative order is preserved. That means, like, let's say I have an A here and a B here, okay? And in my final string, like this is my initial string, and in my final string, I have an A here and a B here. Okay, and there are no A and B in the other places. Like let's say there are all C's. So my point is that just focus on this A and B. It can never happen that this A crosses this B. Okay, it is not possible. It's just not possible because either this B will stay in its place or it will go one step ahead. And same for A. Either this A will stay in its place or go one step ahead. So like in one operation, either this A will eat up this B or both will move ahead, right? Like let's say from this we make A B C C, right? So this A has moved ahead, okay, and from this we can make, let's say A C C. So basically A has moved here and it has eaten up this B. So either this can happen or maybe we can make uh, B C. That is A has moved ahead also and B also has moved ahead and eaten up this C. So, but this can happen. Like either both of them can move ahead, or A can eat up this B, but A cannot jump ahead of this B. Like it can never become BA. It can never become BA, right? That's one observation. So until here, do you guys get it? Yeah. So essentially, you have to just find out some letters. Like you have the final string, right? You have the final string. You have the initial string. And let's say if this letter is not there here, then you have to get it from somewhere else. That is, you will find some place where it is. Like this, let's take a test case. The test case are pretty nice for this one. Yeah, so ACABB, ACABB, and triple ACA. Okay, so here you can see you want to make this A, right? But you don't have an A right here. So what you will do is you will transport this A from here. Okay, like you will just choose this A and you will move it right here, right here. Okay, so you will move this A right here. Then you have this C. So first of all, if you are moving this A right here, then of course if there was a B here, let's say there was a B here. Okay, if there was a B here, then the answer would have been no. Why is that? Like I just changed this C to a B, right? And there was already B here. So why did the answer become yes? Say no. Like why did the answer become no from yes? If I just put B here, then the answer becomes no. Why is that? Because when you are like transporting this A from here, then this B will be deleted, right? These B's will be deleted. So you cannot really have them here at the end. Like after A comes here, this B has to be from someplace before it. Like uh, this B has died after this A ate it. Okay. So therefore there cannot be a B here. Like if you want a B here, then it has to come from somewhere before this A. Right? Like let's say if there was a B right here instead of this A. Right? Then you could have possibly gotten a B here. Okay. But right now you cannot get a B. So let's just change it back to the original problem. So okay, you can get an A right here using this A. Then you can get this C right here using this C. And you can get this A right here using this A. This also using this A and this also using this A. Because you remember our operation allows us to duplicate. Like when we move ahead, when this letter moves ahead, it leaves its mark, right? Like as you could see here, uh, this A, B, C, D, E. When we moved ahead this A, there are two A's now, right? So basically, you can rely on the same element for the multiple positions. Like all of these three A's are relying on this single A, right? So basically, for every element, like for every element, you have found out that which position should we come from, right? And then you can simply keep moving them until you get satisfied, right? Like basically, if this is your string S and this is your string T, and you know that you want this A to be right here, like you want this A to be right here, this C to be right here, this A to be right here, and right here also, and right here also. So you can simply do the operations and move these to the right. So let's say uh, you shift this, like you make this as, like you will shift this A right here, then you will make it C, then you will shift this A right here, and then B. Then from this you will do A and CA, right? So this is your final target. So your aim is, like, the next step is just to map the elements, map the elements of T into S. Okay, cool. So this is what the second step is. That just map all of the elements and say that where are they coming from. Like if you have this test case, A B C D E, A B B C C, A B C D E, and A B B C C, then this C will come from this C will come from this B will come from this B will come from this, and this A will come from this, right? So this is what the mapping you can make. Okay, and then after that you can simply keep shifting it according to your needs and just stop at the point where all of them have been placed, right? But now it becomes an implementation problem. Like, how do you implement this? What is the easiest way to implement this? So actually, I'll just show you how I implemented it. Okay. So what I did was I made a vector. Okay. Like, let's say this is the test case. The index are 0, 1, 2, 3, and 4. Right. So I just made a vector which is showing that which index do I want here. Okay. Like on this fourth index, I want 2. The second one, right? On the third index also, I want 2. On the second index, I want 1. On the first index, I want 1. And on the zeroth index, I want 0. Right? So I want finally this thing to occur. I want 0, 1, 1, 2, 2. And initially, I have 0, 1, 2, 3, 4, right? Initially, I have 0, 1, 2, 3, 4. And I want to make it 0, 1, 1, 2, 2. So now it becomes easier. Like at every index, if you already have what you have, like currently it is 0, 1, 2, 3, 4, right? And you want it to be 0, 1, 1, 2, 2. So what's the next step? Like let's say this is the first initial string. So what is the next step? In the next step, if you already have your desired target, like we have 0 here and we want 0. So we'll just put that, right? Let's say we have 1 here, like we have 1 here, sorry, we have 1 here and we want 1. So we'll just put 1 here. Then, but we have a 2 here and we want a 1. So actually we will take the previous one, like we will forward the previous one. Okay. Then we want a 3 here, but we have, sorry, we want a 2 here, but we have a 3. So we'll take the previous one. That is, we'll make a 2 right here. We'll make this one right here. Okay. Then we want a 2 here ultimately, but we currently have a 4. So again, we will take the previous one. Like we will shift it, right? So we will keep doing this until all the elements are satisfied. So like we want a 0 here and we have a 0. So we'll just keep the 0. We want a 1 here and we have a 1. So well, I'll keep a 1. We want a 1 here and we have a 1. So I'll keep 1. We want a 2 here and I have a 2. So we'll keep this 2. And we want a 2 here, but we have a 3. So I'll keep this 3. I'll keep this 2 right here. Right? And then you have like this answer. Like this is the answer. Like they are the indices. And you can finally print this thing. Like you can just print S of the index. Like you have the string S, right? The original string S. So you can just iterate through this vector of vector and print the S of index for each index. Like just translate this back into the ABCDE form, right? So this is what we can do. I'll show the code also that it might be more clear. Yeah, so do you guys understand now? Like about this problem? I'll show the code. Let's show the code only. Like this was only implementation to be honest. Yeah, so first of all, I have string st, c in st, and just ignore this thing. Okay, ignore this. And we have this vector of element vn. So what is this v? This v is just what we want, like our target. Like we map this c to this c, right? So basically this vector 0, 1, 1, 2, 2, this is our v. Okay. So what I'm doing is I'm trying to map. So for that I have a pointer. Like to implement this, what I have used is a pointer which is initially at the end, right? And so let's say you want to map this C. So you will move this pointer backwards until you find this C, and then you will map it to that. Then you will go one place behind, and then you will see that the pointer is already at C. So you will map it to that. Then you will go one place behind. You will see that this pointer is at C, but you are at B. So you will move the pointer backward, and then you map this, move the pointer backward, and map this, right? So this pointer is there initially at n minus 1. And for each index from minus 1 to 0, I will find out the mapping. So while p1 is greater than or equal to 0 and s of p1 is not equal to t of I, then p1 minus minus. And if p1 is less than 0, that means we did not find any mapping for our current ti, so we cannot really make the string. So c out minus 1. And otherwise, um, just the mapping of vi is p1, right? And also I'm taking the maximum distance. Like I am maintaining this maximum max variable, which is storing the maximum distance. Like see, in this mapping, the distance is 2, right? In this, the distance is 1. In this, it is 1. It is 0. It is 0. So the maximum is 2, right? So I'm just maintaining that, what is the maximum distance. And that will be the number of operations actually. Like since we want to shift this C 2 times, therefore we will have to do the operation 2 times, right? So if MA, if it is greater than K, then C out minus 1, because they have said that if the number of operations, if it is not less than equal to K max, then just print minus 1, right? Okay. Then I will have this loop. I have this loop which does this thing which I showed you. Like basically, initially we have 0, 1, 2, 3, 4, right? You can see initially we have 0, 1, 2, 3, 4 in our string. Then we are trying to create a new string. So this last is stored in this last vector. Okay. Then this temp vector is what I'm making. Like this vector that I'm making, it is in temp. Okay. And this t answer is just uh, the vector of the final answer, right? So like I'll push back these vectors into my t answer. Okay. So right, temp of 0 equals class of 0. There's only one option. Temp of 0 would be last of 0. Then I'll iterate from 1 to n. From 1 to n I'll iterate. If the last of j, that is currently whatever we have, if it is not equal to what we want, the v of j, then we will shift by 1. Like we will shift by 1 if it is not what we want. And if it is what we want, then we will just keep that. Right? So this is how I will make the temp, like the new one. Right? And then I'll push back it into my vector of vector. And I'll make last equals to temp. Right? So I'll do this a number of times because I know that I will have to do these many operations. Okay. And I just asserted that my last, like, finally, whatever I got, that is equal to V, like, whatever I want. That is my answer is correct. Like, if my answer wasn't correct, then this would be a runtime error and it would throw, like, it would tell me that, I mean, I would get runtime error as my verdict. So I would know that I have messed up somewhere, right? So I just inserted this and finally just print the answer. Like this t ans, just print s of x. Like for all the indices in t ans, just print s of x. Okay. What will happen if we have ABCD as s and ABCD as t? Then it is not possible. So see, you want a B right here, right? But you cannot get a B here because this B cannot jump over the C. Like the relative order is maintained. So this B cannot jump over this C and therefore it is not possible. Like in the code, what will happen is this B will be mapped to this B, right? Then C will not get anything done. Like we will find out a mapping for C. We'll try to find something for C. The pointer is here, right? So when we are at C, the pointer will go to the left, and again it will go to the left, and it will be -1. So we figured out that we do not find anything for C, and so we'll print -1. How the count is counting, like when we count one. I don't understand your question. No, not from current index. Like what we are doing is we are, let's say I have this, okay. Then my algorithm is that I'll start out a pointer at here. I'll start a pointer here, and so first I'll check for the C. Like I'll find out a mapping for this C. So I'll move the pointer until I get to C. So my pointer is here now, and the mapping is like this. Then I will go to this D, and the pointer will still say it will still stay here only. So this D is not applicable. So this pointer is here, and if we move to the left and again move to the left, we won't find any D. Okay. But yeah, if like let's say you have this, sorry, let's say you have ABCCE, then this E is there, this E is there. Uh, when you check for this, so this is the mapping, then the pointer will move here. Like when you check for this C, you won't stay at this E. You will move the pointer right here. Okay, if that's what you are asking. Like you will, that's why this line of code is there. That P1 equals to min of P1 comma I. Okay. Actually, this is what I messed up in my first attempt. Like in my first submission, this line was not there, and therefore it was giving wrong answer. Or no, this two is the number of operations. Two is the number of operations that we are doing. So since we are printing two strings, first string, second string, so therefore we'll print two. And if you want to know that how we calculate the number of times, like the if you want to ask that what is the number of operations, like how do we find that out? So the thing is that it is just the maximum of the distance. Like see, if we have A B C D E and we have A B B C C, so this C is mapped to this C. So like here the index is 2, here the index is 4. So 4 is mapped to 2. That is you want to move this C two times, right? And in one operation you can only move it one time, right? So you have to do two operations to move this C. Similarly, to move this C, you will need one operation. For this B, you will need one operation. For this B, you will need zero operations, and for this A, zero operations. So maximum is 2. Like maximum distance that you need to move is 2, and therefore you need two operations only. Because in one operation you can only move one right. No, I mean before submitting, that's not how it works. Like that's why wrong answer penalty is there, right? If there was a place to submit to check, then there would not have been any penalty for wrong answer because no one would submit until they got correct. Sorry. Okay, any doubts, anyone? No, we won't discuss E. So, any more doubts? If not, then I will take your leave. I guess there are no doubts. So, I will uh, say good night now, I guess. Bye, everyone. I hope you understood this string. I have got a little cough, so it might be like little bit difficult to understand me, but okay. One more time that pointer one. Pointer one. So what I said, like I'll repeat it. If that's what you're asking, then fine. A B C D E. So what we want to do is we want to map. Like we want to map this C to the nearest one, this C to the nearest one, this B to the nearest, B to the nearest, and A to the nearest one, right? So for that, what we'll do is we'll keep a pointer. Like we are here, right? So we'll keep a pointer here, and we will keep moving it to the left until we find out a C, right? So this is not a C, so we move to the left. This is not a C also, so we move to the left, and this is a C, right? So this is the mapping. Then we we go to here, right? So as you can see, it is already C. So you will map this like this. Then you go here. So we want a B, but it is C. So we'll move to the left, and we have a B. So the mapping is like this. Then we go here. So mapping is like this. Then we go here, and since we want it to the left, like since we want that our mapping is towards the left, right, and not towards the right. So we'll have to place the pointer here now. Okay. So like for example, if we have ABC and we have ACC, or yeah, okay, ACC. Then if we give a pointer here, so it will map to this, right? Then we move here. So we have to move this pointer here as well. So even though this is C, but we cannot map it like this. We cannot map it towards the right, right? So we'll have to move the pointer to the left. Okay, that's how it works. Okay, all right then. Bye everyone. I hope you understood. I'll see you guys later.